Now see here, in this question, a converging beam of light forms a sharp image on a screen. Suppose you have taken a screen over here and the converging beams are actually forming the image at this point. So, this point we can take as O here, this is the point of the screen. A lens is placed in the path of the beam. Suppose you place any lens over here, this I have taken line as a lens because we do not know what is the nature of the lens. So, a lens is placed in the path of the beam at 10 centimeter from the lens, this distance is here 10 centimeter. Now, the screen has to be moved 8 centimeter away from the lens to get the sharp image. Now, the image which were initially here, now it is formed somewhere here. So, obviously, the image is obtained at this point. So, this whole distance from here is, it was initially 10, now it is 8 centimeters. So, that has become 18 centimeter. So, now you have to find out the focal length of this lens. By knowing the focal length, we can get the nature of the lens. So, we can use 1 upon f is equal to 1 upon v minus 1 upon u. This was acting as a virtual object. So, it was here 1 upon 18 minus 1 upon 10, and that we can take here 180 and here 10 minus 18. So, here we can write 1 upon f is equal to minus 8 upon 180. So, f is equal to minus 180 upon 8. So, f can be written here, that is here minus 22.5 centimeter. This is the focal length. So, we are getting focal length is in negative with the negative sign, and we know that thing concave lens has got the focal length with the negative sign. So, this lens which I have used here, that is actually a concave lens, right, and now and the focal length which has 22.5 centimeter.